Good afternoon, everyone. This year, this is the first class on Saturday of mathematics. Yeah, good afternoon to everyone. Good afternoon, Ravinder sir. Sunana ma'am. Yesterday we have discussed the formulas and the first and second question we have done of the first exercise. So today we are starting with the third question of 13.1. Yes, I am just starting with this question in 1 minute. A toy in the form of a cone. A toy is in the form of a cone of radius 3.5 mounted on a hemisphere. Means this cone is mounted on a hemisphere. So let us make a hemisphere first. The cone is mounted on this hemisphere. So this is the shape of the toy. And the radius of the cone is 3.5. Mounted on a hemisphere. So radius of hemisphere is also 3.5. Now the total height of the toy is 15.5 centimeter. So what will be the height of the cone? For that, just see what is the radius of this hemisphere, that is 3.5. This is also the radius and this is also the radius of hemisphere. So that's why the height of the cone is 15.5 minus 3.5 from total height of the toy minus the radius of hemisphere. Then you will get the height of cone, that is 12 centimeter. 15.5 minus 3.5. Now total surface area of the toy. See, in this toy we'll be able to just imagine this toy. In this toy you will be able to see the CSA of cone because circle is hidden inside. So you will be able to see the CSA of cone and CSA of hemisphere. So just calculate CSA of cone and CSA of hemisphere. You will be able to calculate the total surface area of the toy. Right, radius of cone and radius of hemisphere is the same. That is 3.5 centimeter. So which can be represented by variable r, letter r. Okay, small r. Then height of cone, that is 15.5, the total height of the toy, minus the radius of hemisphere, that is 3.5. So 12 centimeter is the height of the cone. So total surface area of the toy is equals to CSA of cone plus CSA of hemisphere. CSA of cone pi RL and CSA of hemisphere, that is 2 pi r square. Out of this we can take pi r common because r is same in both the cases. So L plus 2r will remain inside. Now as we do not have L, so let us calculate L inside. L is equals to under root h square plus r square. So L means slant height, and that is under root 12 square plus 3.5 square is 144 plus 12.25, and ultimately it is 156.25, and it is 12.5 centimeter. So L is 12.5, you can put here, and the value of pi 22 by 7. Multiply by R 3.5, then L 12.5 plus 2 into R, that is 3.5. Doesn't this cancels out? 0.5, multiply them 11, then 12.5 plus 7. 3.5 into 2 is 7. Now 19.5 multiply by 11, so it is 5 point, then 4, then 1, and this way it is equal to 214.5 centimeter square. Note it down. It is your choice. You can calculate this L in the beginning also. I have calculated here this way. So this is total surface area of the toy. As in the formula of cone, this L comes, so means a slant height is required. So that's why it is required to calculate in surface areas of cone always. Note it down. The next question. A cubical block of side 7 centimeter is surmounted by a hemisphere. Means there is a cubical block, and on that cubical block there is a hemisphere. Okay, so making a cube. But this will not work. We'll make in that way only to make you understand better. This way of cube. See on this cube, where the side is 7 centimeter, hemisphere is surmounted. What is being asked? What is the greatest diameter the hemisphere can have? The greatest diameter the hemisphere can have is equals to the side of the cube, because the side of the cube is 7 centimeter. So the longest diameter that this hemisphere can have, if it is placed on a cube, and that can be 7 centimeter if it completely covered the cube. If the hemisphere is completely covering the cube, means the circle is completely covering, then it is 7 centimeter. I don't mean that it will cover the corners. It will not cover the corners. Okay, that will be left. Side of cubical block is 7 centimeter. Greatest diameter hemisphere can have is 7 centimeter. Then if the diameter is 7, then radius is 7 by 2 centimeter of the hemisphere. Then we have to find the surface area of solid. Okay, then surface area of solid. In this, what you should do, first of all, calculate TSA of cube. In TSA of cube, all the 6 faces will be covered. Imagine this cube and all the 6 faces are covered with this. Means with, if you are calculating TSA, total surface area, then all the 6 faces, the area of all the 6 faces we are calculating. Okay, but this part is covered with circle. Okay, out of this face, no, this part is covered with circle. Therefore, the surface area of this circle will not be able to calculate. So that's why subtract area of base of hemisphere. Okay, so first of all, TSA of cube, then subtract this circle because it will be hidden. This will hide the area on the cube. Fine. After that, we have CSA of hemisphere also. So then plus CSA of hemisphere. See, the circular base of the hemisphere will cover the cube from one face, and some of the area will left here. So that's why out of total surface area of cube, only one circle is covered. So that's why that is subtracted. And after that, CSA of hemisphere will be calculated. Now just write all the formulas. TSA of cube is 6a square. And area of base of hemisphere. Base of hemisphere means circle. That is pi r square. Plus CSA of hemisphere, that is 2 pi r square. Now 6a square minus pi r square plus 2 pi r square is plus pi r square. Now put the value. (22 by 7 into r, 7 by 2 into 7 by 2. This and this cancels out, this and this cancels out. So it is 6 into 49 plus 7 by 2, 77 by 2. So 6 into this 49, 294 plus 38.5. So 0.5, 332.5 centimeter square. See, so to make the calculation easier is in your hand. If you are solving it smartly, first of all, write the formulas being used, then solve those formulas if it is possible. Take the common if it is possible. After that, calculation will be very easy for you. See, I have solved this first of all. This and this. Minus pi r square plus 2 pi r square is plus pi r square. Then I have put the values. Done. Next. Fifth question. A hemispherical depression is cut out from one face of a cubical wooden block. Again, the diagram is somewhat similar. Now a cubical depression is cut, no, and a hemispherical depression is cut out. See this? A hemispherical depression is cut out from one face of a cubical wooden block. So let this be the one face from where a hemispherical depression is cut out. Such that the diameter L of hemisphere is equal to the edge of the cube. It means the diameter of the hemisphere is L and the same is the side of cube. Okay, so write now this is a hollow hemisphere, means this is a depression that is cut out from this cubical block, and where the diameter and the side is same L units, we have to find the surface area of the remaining solid. So what is the solid that is remaining here, the left out solid? The same formula we have to apply. TSA of cube, subtract this circle because this circle doesn't exist now. I know because it is cut out now. So we have this as the surface area only at the top. The corners are only left. So that's why out of total surface area of cube, subtract this circle, then add CSA of hemisphere, same as the previous question. Right, diameter of hemisphere is equal to side of cube, that is L units, and radius is equal to L by 2 units. Then surface area of solid is equals to TSA of cone minus area of that circle plus CSA of hemisphere. So TSA of cone 6a square minus pi r square plus 2 pi r square. Same formula exactly. Here the side is L and pi, keep it pi only because L is also not given, then why there is a need to open pi. Then R L by 2 whole square. So 6L square plus pi L square by 4. Taking LCM, 24L square plus pi L square by 4. And if you want to match with the answer written at in NCERT at back, then just take this L square and 1 by 4 common. L square by 4 we can take common. 24 plus pi will left inside. Square units. If you have any type of problem or confusion in the figures or why it is happening or why so, then you can ask. Otherwise, this is the solution. Just note it down. Note it down. Next. Question number 6 now. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its end. Okay, then let us make this. So let us make these hemispheres. So here the diameter is 5 of the hemisphere and the full length of the capsule is 14 mm. So 14, say this, the radius of the hemisphere will be 2.5, 2.5 here and 2.5 this side. Okay, so these are the radius of the hemisphere. Now out of the total length, subtract this 2.5 and 2.5. From 14, subtract 2.5 from here and 2.5 from there. Then you will get 9 millimeter. That is the height of cylinder in between. Right. Diameter of hemispherical ends or hemisphere, that is 5 mm, and radius being 5 by 2, that is 2.5 mm, and height of cylinder in the between, that is 14 minus 2.5 minus 2.5, that is 9 mm. Okay, and the radius for the cylinder is again still the same. Find the surface area. So surface area, see the circular ends are, these circles are hidden inside the capsule. So surface area of capsule is equal to CSA of cylinder. CSA of cylinder plus 2 into CSA of hemisphere. That is 2 pi RH plus 2 into 2 pi R square. So 2 by RH and 2 by R square. So we can take common here also. Multiply it first. It will become 4 by R square. Take 2 pi R common. It will remain H plus 2R. Now put the values 2 into 22 by 7 into R. That is 5 by 2 or 2.5 you can write. Then H is 9 plus 2 into 2.5. 2 and 2 this cancels out, so it is 110 by 7, and here 9 plus 5, that is 14. Cut this 2, that is 220 millimeter square. Note it down. This is the answer. Next. Question number 7 now. A tent is in the shape of a cylinder surmounted by a conical top. So it's a cylinder first. Then there is a conical top. This is made here. And if the height of the diameter of the cylindrical part, height and diameter of cylindrical part are 2.1 meter and 4. So height is 2.1 and the diameter is 4, which will be the diameter of the cone. And the slant height of the top is 2.8 meters, everything in meters. Find the area of the canvas used for making the tent. Okay. So tent is in the shape of a cylinder with cone at the top. So it is a tent. Then tent will be hollow from inside, obviously. Then CSA of cone and CSA of cylinder will be used in taking out the area of the canvas that is used for making the tent. So just write radius of cone is equal to radius of cylinder, that is 4 by 2, 2 meter. Then height of cylinder, that is 2.1 meters. So let us represent the height of cylinder by capital H, and or you can represent by small h even. No worries. Here we have not to use the height of perpendicular height of cone. Height of cylinder is 2.1 meters, and slant height is given 2.8 meters. Then area of canvas required. So how much cloth will be required for this? That is CSA. In this tent, CSA of cone is made and CSA of cylinder is made. That's it. CSA of cone pi r L and CSA of cylinder 2 pi r h, where we can take pi r common. L plus 2h will remain inside, and where we have to calculate L. L is given here. Why to calculate? It is given 2.8. So pi 22 by 7 into r, that is 2. Then L, that is 2.8. Then plus 2 into 2.1. So 44 by 7, that is 2.8 plus 4.2. That is 7. 44 meter square is the canvas required for making the tent. After this, we have to calculate in the question the cost of canvas required. So 500 rupees is for 1 meter square. So cost of canvas is equals to rupees 500 multiplied by 44, then multiply them. 22,000 rupees is the answer. Note it down. Then one more question we'll do now. From a solid cylinder whose height is 2.4 and diameter is this, a conical cavity of the same height and same diameter is hollowed out. What does it mean? That there is a cylinder and a cone is extracted out from this solid cylinder. So this cone is extracted out from this. This part is taken out. Now this is empty space inside the cylinder in the shape of a cone. Rest is all filled with the solid. And where the height of this is given 2.4. So 2.4 will be the height of cone and cylinder each, and diameter is also same, that is 1.4. And find the total surface area of the remaining solid. See the total surface area of this solid. CSA of cylinder plus base. Because this is a solid cylinder, so it is covered from everywhere. Okay, so CSA of cylinder plus base. Base is not hollowed out, that is covered. And after that, the top is, there is no circle in the at the top because that is hollowed out in the shape of a cone. So we have CSA of cone now. See, suppose this solid cylinder is there in your hand, and the surface area that you can touch, the area that you can touch will be the CSA of cylinder, CSA of cylinder, CSA of cylinder, and the circle. So that's why CSA of cylinder plus area of circle, and we'll be able to touch inside the CSA of cone also. So that's why CSA of cone. Right, height of cylinder is equals to height of cone, that is 2.4 centimeter, and radius of cone and radius of cylinders are same, that is 1.4 by 2, 0.7 centimeter. Now let us calculate L. H square plus R square. H is 2.4 and R is 0.7. 576 plus 0.49, 6.25, that is 2.5 centimeter. Now surface area is equals to CSA of cylinder plus area of base plus CSA of cone, that is 2 pi RH plus pi R square plus pi RL. So we can take pi R common from everywhere. So 2H plus R plus L. So pi 22 by 7 and R being what is R? R is 0.7 and 2 into H. H is 2.4 plus R is 0.7 plus L is 2.5. So this and this cancels out. 0.1 is 2.2, 4.8 plus 3.2, 8, it is 17.6 centimeter square. This is the exact answer. And they are asking us to calculate the nearest centimeter square. So nearest answer will be 18 centimeter square. So just round off the answer. Okay, so class is over for today. The last question of the exercise is left. That will continue from Monday. Bye, take care.